Alright, I'm going to take you through the steps on how to calculate the resultant force and direction of a vector. And so first of all, I wanted to explain our diagram here. Basically what we have is, let's say that three ropes are connected, and that would be where 0, 0 is on our system here. And one person is pulling at 120 newtons. That's the force they can use to pull with, like tug of war, and they're located 75 degrees from that x-axis. Person B is down here. They can pull with a force of 130 newtons, and they're located 35 degrees in quadrant 3 from the y-axis. And finally, person 3 can pull at 140 newtons, and they're pulling 40 degrees in the fourth quadrant from the x-axis. And so basically what we're deciding is who would win this tug-of-war contest, person A, person B, or person C. So that's the reason we're doing this calculation. And so the first thing that we have to do is we have to sum the forces in the x direction. So the sum of the forces in the x direction. And so to write that, we will say we want to sum of the forces in the x direction. They are going to be equal to our first vector here, 120. That's the magnitude of it, times the cosine of 75 degrees. We're going to add that to, because it's the x direction and cosine is adjacent over the hypotenuse, the adjacent angle, or the adjacent is the x, so that's why we're using cosine. All right? And so then we add the second vector, which is 130 newtons, times the cosine. Now we have to make our angles from all the same place. And so this case, instead of using 35 degrees, because 35 degrees would technically be in quadrant 1, we have to figure out where we are in relationship to 360 degrees. And so I know that this vertical line is at 270 degrees, because if I have 90 plus 90, that equals 180, and plus another 90 equals 270. So if I take 270 and subtract 35 from it, I get 235 degrees. And so that's the angle I'm going to use, because the angles have to be from measured from the same place. All right? And so then the next thing I'll do is I'll add our last vector, 140 times the cosine of, this time we're in the fourth quadrant, and so I take 360 degrees minus 40, and I get 320 degrees. All right. And so to do that on my calculator, I'll take 75, I'll hit cosine, then I'll multiply that number by 120. And I get 31.058, or something close to that. Next one, 235 cosine times 130 equals negative 74.565. Next one, 320 cosine times 140, and I get 100 plus 107.246. So I add those things up, and I get the sum of the forces in the x direction is equal to 63.74 or something close to that. All right, so that's the first step here. The next step is to sum the forces in the y direction, and so we'll use the same thing, except now we'll use the sine function because we're doing the opposite over the hypotenuse, because now we are in the y direction. And so again, I will have 120, and this time the only difference will be sine of 75 degrees plus 130 sine of 235 degrees plus 140 sine of 320 degrees. So again, I'll do that on my calculator. 75, I'll hit the sine function, multiply by 120, and I get 115.91. Next one, 235 sine times 130, and I get a negative 106.489. And lastly, 320 sine times 140, and I get a negative 89.990. Add them up. And I get an answer of negative 80.57 or something close to that. All right. And so now we are going to calculate the resultant magnitude based on those two numbers. And so what we've done in the x direction, we've gone over 63.74 newtons. So I'll go ahead and write that in. .74, and this is the sum of the forces in the x direction. Then since this number is negative, I'll go down from that point, negative 80.57, and so we know that our answer is going to be in quadrant 4. All right. Now to calculate the resultant angle, or excuse me, the resultant magnitude, we are simply going to use Pythagorean's theorem. Because we have these two things, now we can calculate the hypotenuse of that. And so it is equal to the square root of x squared plus y squared, x squared 63.74 squared plus negative 80.57 squared, and square root of that. Type it in on your calculator and you get 102.73. And so once you have that number, we can then use all of our information to calculate the resultant angle of the vectors. And so to do that, to calculate the angle, we're going to use the tangent function, which is adjacent over the hypotenuse. So the tangent of theta is equal to the opposite over the adjacent tangent of theta is equal to, the opposite in this case was negative 80.57. The adjacent angle that we're trying to figure out is 63.74. The adjacent side of the right triangle, 63.74. So I'll divide those two numbers and I get negative 1.264. That equals the tangent of theta. And so now theta, to get tangent by itself, theta is equal to negative 1.264 times the inverse tangent. So to type that on my calculator, I would type 1.264 negative, and I would go second inverse tangent, and I get an angle that is equal to negative 51.65 degrees. Now, one thing that we need to know is we are in the fourth quadrant here. And so if we take that 360 degrees, and so our answer is going to be the angle is equal to 360 degrees because it's in the fourth quadrant minus the 51.65 degrees we got. We get our resultant angle of 308.35 degrees. And so what we're saying is that from 0, our resultant vector is 308.35 degrees, and it has a magnitude right here of 102.73. So if we were doing tug of war, this person 3, would win the tug of war contest. And so that's how you calculate vectors.